Hi guys, we're up in my workroom. Can have a little look at this electric motor. In one of my recent videos, I actually managed to burn this out in some way or other. It comes out of a lint remover or a fluff remover, and I was using it to power a little electric car, and I think I put too many volts through it and it stopped working. I've got 3 AA batteries here. If I put them across it, nothing happens. So I'm going to take it apart and see if we can fix it. The usual way is to lever out these little tabs. Oh, let's zoom in a bit. Right, there we go. Lever out these little metal tabs. So you can slide the metal body off. That's the brushes. There's our motor. Oh, I think I can see the problem. Don't need to go any further, to be honest. You can see it's actually melted the wire there. I think this was a, what would it have been, 1.5 volt battery it was intended to run on, and I think I was using a LiPo, either a 1S or a 2S. In fact, I think I even put a 2S on it, so that would have been 7.2, 8.4 volts potentially. No, 7.4, 8.2 volts. 7.4 nominal voltage, 8.2 freshly charged. And we can see, can I zoom in a bit further? Oh, out of focus. Back a bit. Come on. Yeah, we can see where it's gone silver, where it's melted. So we're not going to fix that in a hurry. You can even see the plastic lining there's gone a bit bobbly. So that's what happens if you stick too many volts through a motor that can't take it. Actually melt the windings. Yeah. So there we go, not much I can do to that. I could rewind it entirely. That might be a little project to do at some time or other. But there's no quick fix to that. Well, I'm looking for a source of wire that I can rewind this coil, or armature. I've got this little coil of wire, which came from a different project. Or I could take this apart, because if you peek inside there, we've got plenty of copper wire. No idea what gauge it is. It's significantly thicker than that, but I think it's thinner than that. And to get this one apart, it looks like I've got to drill out these rivets. So I'll do that and see if we can salvage some of the wire off it. That was fairly straightforward, just drilled the heads off those rivets. That one needs a little bit more. The others are free. Just do that one again. So the question is there any way of salvaging that? Easily? And the answer looks like no, because each wrap goes around and then through. So I'd actually need to separate this. That's a pain. Let's get the bottom off anyway. See, it's fairly water damaged there. A couple of nice bearings. This is out of a washing machine. Well, those bearings might be useful for something. I'll save them. This is sort of sealed in place. It's got a plastic wrap around each winding. It looks like it's also sealed in. Some sort of silicone or something. No, I think this is a dead end. I can't see any simple way of getting that out. Somewhere I've got a coil of wire that I've recovered from an old television. One of the real old type with a cathode ray tube, CRT. So I could cut all this string, but that won't help me. You can see each one goes down, through, up, down, through again. How frustrating. I'm sure that would be useful for something. Still works an electric motor if I really wanted it to, but I recovered it so I could pinch the copper out of it. We'll put that to one side and forget about it for now. Yeah, I've slipped it back together. I'll put that back in my spare bit straw. This is getting a bit frustrating now. I've hunted high and low for my spare coil of wire and I can't find it. So, quick demonstration of a lazy fix for no good reason, because I can take this motor apart, put the armature from there into there and we'll have a working motor. Why take one apart to repair another one? For demonstration purposes only. This one I've already loosened the tags so I can get it out. You'll see that armature is much smaller than that one. So There's less coils, less power. Can you see that? It's about half the length. But that little stop there, if we line it up with the stop on that one, then the armatures line up, so the length of the motor is the same. So if I pop that in there, taking care to part the brushes, and get this one back on the right way round. There's a little notch there that fits there. Around a bit, there we are. Just stick that on there so we can see if it actually works. That one there. That one there. Oh. And there we go. But I wouldn't really call that a fix. So that's just taking one motor apart to make another one work. So I guess all that's really left is to unwind that armature, if we can, and use this wire, which is much thicker. Thicker will be lower resistance, so it will draw more current. So that's what we'll do. We'll take this one apart if we can. Need to desolder the wires there. I'm just looking to see which way round they go. That's over the top that way. So when we're winding it, it actually goes... To be honest, it wouldn't make much difference as long as we do all of them the same way, all three arms of the armature, then we should be okay. Apart from the ones that have melted together. See, that one's gone. I don't think there's much point in videoing me trying to undo this, because where they're melted together I'm just going to have to break them. So I'll get on and do that, and then we'll see about rewinding it. I probably should have filmed the first bit of that, because as soon as I tried to pull a bit off it just broke where it's melted. So I'm going to cut through them. Pull off a few more in one go, if we can. I'll get on and do that. These little blue plastic bits are off the end of the armature. They protect the wire, stop the metal armature actually digging into the wire as you're winding it round. But you can see where it's overheated, the wire's actually melted into it. That's why it's in such a poor state. Anyway, that's all the old armature wire. I'll just throw that away. Then I'll wind that thicker stuff on. Obviously not as many coils or turns, just to see if we can get it working. Many years ago, when I was a youngster, I used to rewind the motors on my slot cars and put thicker wire on. That seemed to make them go faster. But that's not really what I'm doing this for. I just want to see if we can get it working again. Just a quick point. This commutator, the plastic shaft that it's on, or tube's got 3 little pegs sticking out the end, which I don't think we're going to see on the camera because it'll go out of focus when we get too close. But they line up with 3 little holes in the blue plastic former there, or whatever you want to call that. And that makes sure that each plate of the commutator is in the right orientation compared to where the coil is. So we need to go from the solder tag back and round this one, and when we've been round it we go on to the next solder tag, and then back and round that one, and onto that solder tag, and then back, round and round, and end up back on the original one. In fact, I don't know if this one shows it more clearly, if it stays in focus. Are we in focus? No, we're not. Come on, camera. I really don't think that's going to be in focus. But we can just about see the wires. If we start there and go round the outside, it's going round that way, and then from the inner bit it goes up to that one. So when you're actually winding it, you're going to start on that one, go round and round and round, and then you come out at the top there onto that one. That's probably all out of focus. Anyway, what I will do, I'll use this wire, which I didn't want to, it's much too thick, but we'll use it for demonstration purposes. It's enamelled wire, which means it's got clear coating on it to insulate it, so you need to get the enamel off it before you can solder it. Now, generally speaking, you can usually just do that with your soldering iron. If you heat it up enough, the enamel burns away. I don't know if my soldering iron's hot enough yet. So we've now got a bit of solder on the end of this wire. So if I just start the first one, like that, and then it's actually back around there. I'll push that back that way. Now I need to count the number of turns I'm putting on. You need to do them fairly, well, as tight as you can really. I'll carry on doing this and go all the way round, and then we'll see if we can get it to work. Well, there we are. I managed to squeeze 20 turns on each one. And I scratched the top of the wire to get the enamel off it, and then soldered it. I think I've got them all soldered on there. So we'll put it together and find out. Before I put it back together, I'm just going to solder a couple of bits of wire onto these tags to make it a bit easier to connect the battery. Right, put that in there. There was a little white washer on the end there, just to reduce the friction, I guess. Spread the brushes. So he fits in there. Right, that goes that way around. Like that. Right, I'm going to have to edit the video a little bit because I've flattened these batteries now. With the thicker conductors and lower resistance, it's drawing more current, and these 3 AAA rechargeable batteries are pretty well flat now, and it's running, as you can see. Nothing there. Probably a loose battery in there. Let's do that again. Yeah, struggling a little bit. If I use 4 AAAs, again these are getting a bit flat. And it's drawing so much current, these batteries are actually getting hot in my hand here. Now, I could use this LiPo, but that goes the other way. This thing gets hot. Oh, I can smell it. Yeah. So, success. It's all back together. It's all working. But with the thicker conductors, it's drawing more current. And it's actually drawing too much current for these batteries. That's actually quite a warm pack in my hand now. But it works. So, was it an economic repair? No. Was it fun to do? Well, it was interesting, I hope.